Okay, so in this session, we are going to share a couple of thoughts regarding transitioning a on-premise enterprise into the cloud. The agenda for today is to first clarify exactly what this enterprise is, see exactly why we would want to change it, discuss a couple of considerations from an infrastructure and application point of view, discuss the architect role, and then at the end, see about a couple of conclusions, some key takeaway points that would help you when you are involved in such a transition. So let's get going directly with the enterprise. The domain that we are talking about is the public domain. It basically includes absolutely everything involved in managing the society in which we live, whether it's about persons, addresses, buildings, land, companies, social, taxes, everything is included here. So it's quite a huge domain. This domain is divided into multiple subdomains. It's by far the oldest probably domain available. It's been evolving across multiple decades, so we don't expect it to change overnight. These subdomains don't exist individually. They are not divided. They are connected depending on how the data should work. Usually, each subdomain is covered by one application. So it means that we have a couple of teams, and depending on the size of the subdomain, we have multiple teams, each covering the application. So we have tens of applications which are servicing this domain. We have both old and new code. We have tens of technologies. The tenants for this domain are the municipalities themselves. And parts of these applications actually get to the end user. So potentially we have hundreds of municipalities and we have millions of final users. To make things a bit more complicated, a municipality has the opportunity to choose applications from different companies. So we can easily imagine a municipality choosing a couple of applications from one company, a handful from another, and so on. You can imagine that all of these applications need to interoperate quite well. To sum it up, we have a huge domain. We have legacy code, 10, 20, 30 years old. We have new code. We have multiple teams working with multiple technologies, dead, dying, buried 10 meters deep, and new technologies that are fresh and ready for SaaS. Hundreds of tenants, millions of final clients, competitive market, because the municipality gets to choose exactly which applications from which customer, which company they can pick. And historically, it is hosted on-premise in private networks. We can rightfully call it a heterogeneous distributed system. This brings us to the first takeaway point. Indifferent of where you are working in this domain, whether you are working in the teams, whether you are coordinating a couple of teams, whether you are coordinating some subdomains, you definitely have a lot of challenges. So it's kind of awesome working in something like this. You can ask now, why do we want to change this beautiful system that's been working on-premise for the past 20 years? Let's consider a company, randomly call it Centric. It's been providing software for the municipalities for the past 30 years, leader in the market, very nice place. The business likes it and wants to keep it this way. The business always keeps tabs on what's happening in the market, discussing with the customers, seeing opportunities, discussing with the government. And they decide that they need to make a change if they want to keep the leader role for the next 5, 10, 15 years. So they come up with a vision, a business vision. We want competitive, innovative products. We want lower operational costs. Data availability through API standardization, lower time to market, lead a role in the rapidly changing market, strengthen security, and adhere proactively to government standards. The business takes this list of requirements and brings it to the IT department. The IT department, obviously scratching their heads, plan, discuss with other various departments like marketing, legal, financial, and come up with a plan. And the business has to, and they take it to the business. And they say something along the lines of, if we want to fulfill these requirements, then we need to take our new applications, our 10, 20, 30 years old applications, and have them as SaaS products. The business analyzes the proposals, sees the estimations, sees the budgets, approves the budget, adds 50% because we all know that's going to happen, and so the journey begins. But it's not without challenges. And the constraints that we are going to discuss today are related to hosting, infrastructure constraints, centralized management, operational costs, and application transition to a SaaS product. Before going straight into these constraints, I would like us to discuss a bit about the curious case of the Big Bang rewrites. And I'm going to start with a quote from Martin Fowler. If you do a Big Bang rewrite, the only thing you're guaranteed of is a Big Bang. The main lesson that we can learn from this is that we need to consider very well when we approach the idea of rewrites. Think about the risks, think about the business. Will there still be business value at the end of the rewrite? It usually takes 3 or 4 years. Can the business survive? What will the customer say? And if all of these don't convince you to give up the idea of a Big Bang rewrite, then be lazy. Be lazy and choose the simple solution, because sometimes a simple solution with some corners cut, but available in 6 months, is much better than a Big Bang rewrite that's available in 3 years. The alternative is to do an incremental migration, and the most important advantage here is to learn from each increment. This means that we can change fast, depending on the environment in which we are working. We can fail fast. We don't like speaking about failures, but it's not off the table. It's much better to fail in 1 month than to fail in 3 years. And then we can do conditional migration in the sense that we can pick up the most important features, migrate those first, see how the clients react, and then change. First off, hybrid hosting scenarios. We've mentioned that our distributed system is currently on-premise, and we need to take it all the way to the cloud. We cannot do Big Bang rewrites, so we have a period of time, potentially years, in which the system needs to be in a sort of hybrid situation. Some applications are in the cloud, some applications are on-premise. To make things even more complicated, the customer gets to choose when it does the transition. So even though we can have a SaaS product, the customer can say, nope, I don't want it. It's nice, but I want to keep my data on-premise. This means that our application needs to be able to be hosted both on-premise and in the cloud, same code base. Very important. The next topic, 3-tier model. Historically speaking, these applications were living on-premise, and they were in a private network, arguably secure, so not a lot of security considerations were put when writing this software. But when we take it to the cloud, the attack area grows exponentially. We cannot just lift and shift our application into the cloud and expect it to work. If a data breach happens, the consequences can be enormous, financially and also from a branding perspective. So we need changes at an infrastructure layer, at an infrastructure tier, and also at the application tier. So one of the most used models for the infrastructure is this 3-tier model, which basically indicates that we should have 3 tiers, front office, mid office, and back office, each in their own network and properly secure. This way, an attack gets much harder in our mid office where the logic exists, and much harder in the back office where our data exists. Centralized management. Again, when the applications were on-premise, usually the client was in charge of handling everything, making sure that servers exist, enough CPU, enough RAM, enough storage, everything was working properly, scaling, everything was picked up by the client. When we take these applications into the cloud, then it's the company's responsibility to make sure that everything works fine. Sure, the cloud provider gives us a lot of opportunities in terms of hardware and making sure that everything scales, but ultimately it's the company which is legally bound to make sure that everything works okay and we have the proper SLA. At the same time, in our business vision, we had that we wanted lower operational costs. How about we have a handful of people managing the entire system? To be able to do that, we need a centralized dashboard for management. And some of the core services that we should put here are configuration management, authentication, authorization, content generation, API gateway, asynchronous processing, and please fill in the dots with whatever you feel is necessary or can be considered a core service in your system. A good rule of thumb is that if a piece of logic is required in 3 different applications, then it's a good candidate for a core service. You have faster time to market, you have a high return on investment, and then you don't have to reinvent the wheel in each of the applications. And then we can actually get to the application transitioning itself, and some considerations here which I feel are important to discuss. First off, the SaaS maturity levels. It doesn't really matter which are these maturity levels, but it's very important at a company point of view, from a company point of view, for them to exist. It's very important for you to be able to go to pick up 2 teams, any 2 teams, and tell them that you want to target SaaS maturity level 3. They should know from the beginning exactly what that means. Code constraints, same code base, what core services, everything should be crystal clear. Very important for these to exist. Data isolation in REST and in transit. How are you going to store your data? Will it be data per tenant, or will it be some sort of shared data store? It's your basic trade-off between costs and data isolation or security. Hybrid hosting scenarios in the 3T model, we just discussed it and we know what's it about. Integrating with core services. Bear in mind that our applications need to go on-premise and in the cloud at the same time. In the cloud, we do have core services. On-premise, we don't have them. So we need to create our application, transition our application with this in mind. Containerization, very important, whether it's worth investigating whether this is possible. In the cloud, it's definitely possible, and it's usually lower costs, lower hosting costs, but on-premise, most likely it will not be available. Technology considerations, whether we can actually migrate away from a couple of the old technologies that we are using, maybe seeing some new technologies which would make our transition easier. Build and release pipelines, these depend a lot on the cloud provider and what they need in terms of artifacts to be able to host your services. Security improvements, we cannot just lift and shift, we need to make code changes so that our software is secure. Business constraints, automated testing. If we are going to the cloud, we also need to be considering continuous integration and continuous delivery. Potentially, we should be able to release at the end of each sprint, maybe even more frequently. It is impossible to do this without automated testing. The sheer capacity needed to do a full application regression at the end of each sprint means that you cannot do it. It's just not available. And then at the end, we can actually get to the application-specific changes, multi-tenancy, asynchronous processing, scaling, and everything else. This brings us to the next important point, takeaway point. The application code changes are not first in the list. Don't jump into changing the code the second day you hear about the transition. Please clarify your environment very well first. Make sure you know all of the considerations, because all of these points have direct impact on exactly how your application code needs to change. So please don't jump directly into the change. Our last subject for today is the architect role. I'm not talking about the ivory tower architect. I'm talking about hands-on, down-to-earth architects who are not afraid to get their sleeves up, get dirty, jump into a debug session, and discuss it with the teams at least once per week. So these are the kinds of architects that we need in this environment. This is what's needed right now in the IT field. Unfortunately, the role of the architect is not easy in the sense that it's always about trade-offs. I would say that the decisions that an architect needs to take are definitely not the first, second, third, maybe even fourth preferred option. But these decisions need to be taken. Imagine an architect needs sometimes to decide the best out of 13 bad options. Bad options, worst options ever, but that decision needs to be taken. I'm going to pause here a bit and give an example. True story, happened to me 2 days ago. I was on Thursday in a meeting with the business guys, and I was listening into their chat. We were discussing about transitioning an application from on-premise to the cloud. And at some point, one of the guys said something along the lines of, even if we do have a cloud, a SaaS product, we are still going to be doing 2 major releases per year. And I was like, why are you doing this to me? Bear with me. It all starts from the hybrid hosting scenarios. For a pretty long period of time, we need to be the application needs to be able to be run on-premise and in the cloud. Both of these instances are serviced by the same support group. And for the support group, it's much easier, read lower operational costs, to have the same versions. This is a business constraint. You cannot argue with it. It is as it is. Now I have to go to the teams and tell them, hey, you know, we're doing cloud applications, but we still do 2 major releases per year. What are they going to say if they don't know the context? What will someone in 6 months from now say if they don't know the context? So please, before jumping into application changes, read all of the decisions that were made from an architectural point of view. Now, regarding this particular decision, it's a challenge. I always like deprecating decisions. Means we make them better. So it's a matter of time until it gets changed. Don't worry. Stay tuned. Next one, it depends. The infamous it depends. please don't take these words as a measure of laziness or lack of knowledge. Take them as a measure of wisdom. As you've seen in the example, it's very difficult to give a straight answer. Just with a couple of sentences understood, just give a complete answer, final decision. It's impossible. It always depends. But when the constraints are clear, when the light at the end of the tunnel is visible, then the architect needs to take responsibility. It needs to be able to help the teams in their transition to the cloud. The architect needs to be able to provide all of the answers that the team needs, which makes him a sort of jack of all trades. It doesn't matter what kind of question the team has, whether it's infrastructure, whether it's coding, testing, financial, standards, business, anything, nothing is off the table. The team must be able to go to this person and ask the question, and the architect needs to be able to answer it or be able to find an answer and provide it to the team. This means that our architect is an enabler for the teams. At the end, a couple of conclusions, key takeaways so that may help you if you are involved in such a transition. First off, distributed systems are kind of awesome to work in. Definitely you have a lot of challenges, so you can always find your place in a distributed system. Application transition is driven by the business. The business is the one that has all of the knowledge to decide when a transition can happen. The business knows the clients, the business knows if there is enough money to invest and when the return on investment will happen. They do the math. It's their decision and they pay for it. Next off, clarify all constraints before jumping into the application code. The application code should be around the last items in the list to investigate. Clarify everything before jumping into the code. And then at the end, the architect is an enabler. Please don't hesitate to go to this person and ask all of the questions that you need. Don't go around starting to investigate yourself, because the architect is much more in the position to understand and be able to provide an answer. Thank you. Are there any questions? No questions? Okay. Then thank you for joining in, and good luck with your transitioning.